Is it possible to solve this system of linear equations by graphing? Let's solve for y by subtracting x both sides. So we can get the y is equal to mx plus b form of the equation. Here we have the slope is -1 and the y-intercept is 2. That means we have the point 0, 2 to graph. We use the -1 over 1, rise over run, down 1, right 1, y-intercept, and we'll go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1 for the slope. For the second equation, we need a bit more room. We want -3y by itself. So we'll subtract 2x both sides. What we do to one side, we do to the other. We've got a 0 pair. -3y is equal to -2x plus 9. Now what we'll do is isolate the y by dividing by -3. What we do to one side, we must do to the other. Students often skip this step, but I'll show it here. Negative divided by negative makes a positive 2/3 times x, and positive divided by negative makes the -3. The slope is 2/3 and the y-intercept is -3, which means we'll use the point 0, -3. 0, -3 is right here. We'll rise up 2, run over 3. Rise up 2, run over 3. 2, 3. It's looking like the intersection is right there at 1, 2, 3, -1. Now, to be sure, we should take that point and substitute it into both equations. Using the first equation, x value is 3, y value is -1. 3 plus -1, does that equal 2? 3 minus 1, does that equal 2? And yes, 2 equals 2. Second equation, we'll take the 3 and we'll take the -1. Is this equation true? 6 negative times negative is a positive 3. Does that equal 9? And yes, 9 equals 9. We know that 3, -1 is a solution to this system of equations. We could even use Desmos to double check our answer as well. Equation 1 is in red, equation 2 is in blue, and we have the solution of 3, -1. The answer is yes, it's possible, and the solution is 3, -1. Is it possible to solve this system of linear equations by graphing? Well, let's try. Solving for y, we'll subtract x both sides. -y is equal to -x plus 5, and then we'll need to divide by -1. Y is equal to positive x minus 5. Slope is 1, and y-intercept is -5, or 0, -5. Y-intercept, and we'll go slope is rise up 1, run over 1. Rise up 1, run over 1, or we can go down 1, left 1 to get the same slope. And the second equation, we need a bit more room here. We'll solve for y, subtract 2x both sides. 3y is equal to -2x plus 12. To get y by itself, we'll divide by 3. What we do to the left side, we need to do to the right side. We get y is equal to -2/3 x plus 4. The slope will be -2/3, and the y-intercept will be 4 which is the point 0, 4, 0, 4, and we'll go down to right 3, down to right 3, or up to left 3, up to left 3. There's the blue line, but we have a slight problem here. The intersection falls within the square here. We really can't see what the x and y values are. The answer is it's difficult to solve by graphing, unless of course we guess and check using algebra by substituting values into the equation that we think might be true, but that would take a long time. When you're working at home and something like this happens, try to use some technology to help yourself out. Use Desmos. X minus y is equal to 5, and 2x plus 3y is equal to 12. These two lines intersect at 5.4, 0.4. Coordinates are not usually shown using decimals. We need to convert to fractions. According to Desmos, that point is 5.4, 0.4. 5 and 4/10, 4/10, or 5 and 2/5, 2/5, or 25 plus 2 is 27/5, 2/5. Let's use these fractions to double check our work and practice working with fractions. Take the first equation, x minus y is equal to 5, and plug in the two fractions. 27/5 subtract 2/5. Does that equal 5? 25 divided by 5. Does that equal 5? And yes, it does. First equation checks out. We'll try the second equation, plugging in 27 divided by 5 and 2/5. Does that equal 12? 2 times 27 is 54/5 plus 6/5. Does that equal 12? 60 divided by 5. Does that equal 12? And yes, 12 does equal 12. The solution then would be 27/5, 2/5.